Hi, I'm Walt Tamala, owner of TNT General Contracting, a build, design, educate firm based out of Westfield, Massachusetts. Today we have a unique opportunity to work with Decra Metal Roofing and the Westfield Tech Academy in a hands-on demonstration and installation guidelines of the product. I've been introduced to Decra about 12 years ago, and they are one of the premier metal products on the market.
This is a little checklist, just a couple friendly things that'll make it easier for you to be safe. We can teach you all the things in the world about how to work easier and install products better, but at the end of the day, if you go home with a broken back or a broken leg and can't work, or worse, you know, what good is it? So safety is always first. Just some other things to touch on with our product specifically because it's metal. Anytime you're handling it, you definitely want to make sure you've got some gloves on, okay? You'll find, regardless of how you're cutting it, there can be some burrs or little sharp edges along the side. If you're cutting it with any kind of circular saw or table saw, you really want to even go above just having safety glasses. You want to get a full face shield on there because those shards can bounce off your shoulder, pop up underneath your glasses. Has anybody here had the pleasure of having a little metal shard in their eyeball yet? Oh, lots of you guys, wow. So I know it's a little bit of a hassle as you're on the job site trying to, remember to put that shield on and put the cover down. But believe me, that $15 investment in the 2 seconds that it takes to do it is well worth it. Your eyes are kind of important. Okay, and then outside of that, I mean, just typical PPE type stuff. So your glasses, your gloves. You're always going to want to have long sleeves as well. If it's summertime and you just don't like wearing long sleeves, you can buy a cheap pair of like welding sleeves that you can kind of pull up and down as you're cutting things. I call them the LeBron James look, So just be safe out there. So this gives you a grid. You can see all the different parts and pieces that we have with the system. It's pretty much turnkey. I mean, we've got just about everything you're going to need to put a roof on, some of the deck preparation, tearing off, whether you're going over the existing roof or stripping it down. If you are going to go over existing shingles, we do require some cutbacks along the perimeters. Okay, that's going to be your rake ends and across the gables. And what that is, it just allows you to get our starter strips and our rake channels down solid on the deck, screwed in nice and tight so they're not weeble wobbling over those old shingles. Okay, with our system, the starters, as far as a wind protection, when you have wind damage, typically it starts at your eaves or along some type of perimeter, and once that integrity is sort of breached, that's where the rest of the roof starts to peel off. So making sure your perimeters are down is key. This is our starter, and then I've got some more to show you the overlaps. How to set that all down. The lighting may be a little poor, but we'll see it in real time here in a second. The rake channel, everybody here familiar with vinyl siding? Somewhat familiar? If you noticed the locks when I was holding up that panel, it's virtually identical to a vinyl siding panel in the way that it applies. Same thing with the rake channel. If you look at this little red diagram here, it's essentially a J channel that runs up the length of the gable end. You cut your panel and you tuck it inside of it. Okay, like siding, when you're tucking into channels, you're usually cutting back your clip blocks to allow for drainage. We're going to do the same thing with ours. The starter, just to pop back here real quick. Okay, this is one. We have a couple options for starter, but you can see this also looks very similar to the way that a vinyl siding or siding starter would perform. Tucking one rake channel into the other. A lot of guys have a different way of doing it, but basically you're just making some relief notches so you can kind of slot one into the other. So you have continuous water flow coming down your gable ends. When you get up to your peak, you can cut one side clean, take the other side, run it long, flap it over, so you have, again, continuous drainage coming down both sides of that rake edge. Another very important part that a lot of guys tend to mess up, drainage points, okay? Anytime you have a water channel, whether it's a rake channel or a valley metal, it could be a sidewall channel on the side of a dormer. Wherever you get to the base of this channel, you got to make sure that it's draining either off the roof or back up on top of the material below it. I see a lot of times where people will just lay this down on the roof and fill in panels over the top of it so everything's draining underneath the roof system. Kind of counterintuitive as far as how to shed water off of a roof. So always make sure that you've got good drainage points. When we're looking at the eave line, we want to have 1 inch minimum overhang here. Whether it's the rake channel, if it was an inside valley like we've got here or here, you want that valley metal to be extended about 1 inch past. Have you ever seen water run down metal and when it gets to the end it almost rolls back up, or what's called wicking? Okay, so if we were to set that valley metal flush, you know, on any edge, if we were to set that valley flush with our drip edge, it would almost siphon itself back through there. It's just, I'm not sure what the technical term would be. Sort of capillary action, yeah, it's just gonna want to suck it back up. So by putting that extension on there, now it's gonna let gravity be a bit more effective and let that water drip off the roof instead of rolling and sucking back up onto your structure. Okay, so it's key to have good drainage everywhere you've got a channel that's terminating and trying to shed water. The valley metal, as you can see, this is one piece that's laying down here. It's roughly 10 inches wide on either side. It's all one solid piece with a couple of V-grooves to create 2 water channels in here. Panels just tuck up inside. The starter, this is our starter clip with drip edge on an inside valley. This is, if you can see it, it's slotted out. Now that's going to let our valley metal, which is this wide, come down, lay flat on the valley, and stick through that system with that minimum 1 inch. Here you can see the valley in place. We've got it measured out 1 inch past our eave. We're good to go. As we run up the roof line, we're going to overlap our valleys a minimum of 6 inches. If you can overlap it a minimum of 6 inches, you won't need any type of sealant coming across here. That's going to give you enough protection. If you feel like you want to just go above and beyond and run a bead of sealant across there, or perhaps run some ice and water shield, or whatever you want to do to differentiate yourself and try to make a better install, that's fine. But a minimum of a 6 inch overlap. Okay. There's also going to be a valley cap that slides over this sort of center T in the middle. This is going to be a stone coated cap, so it's going to make everything blend. And how you terminate it down at the base is, again, completely up to you and how you want to customize your installs. Most people will just take it, snip it, and fold it down over. It's really up to you. This is just showing a valley draining into the field. Again, this is where a lot of times I see guys install the valley metal and then just fill in panels over it so it's actually shedding underneath the panels down below. Okay, here we've got a fascia from our dormer that's coming over in. We've got some soffit up underneath it, right up in here. I like to, if you can, cut back this fascia and take this panel, slide it all the way into your sidewall here and right up through your soffit. Now you know you've got good solid protection right up through that fascia, that whole transition area, right through your soffit, right into the sidewall. Now we can take our valley metal, run our valley metal down over the top, and we got good continuous flow, particularly in this market where you've got, it's been pretty mild this year, but you get a lot of snow and it sits up there for months at a time. Water melts coming down those areas. Me personally, I like to leave my valleys whole across here. Now our minimum would be cutting it back 1 inch, 1 inch. I like to leave it all the way across just so you have a bigger chute that provides more protection across that area. Kind of like this here. Some people don't like that look. It is a pre-prime metal, so it can be painted, or you can apply our touch-up kit to stone coat it. I prefer the best protection I can get when I'm doing a product, whether it's roofing or siding or windows, and the visual thing kind of takes a small back seat to having the best protection. So for my money, I like to leave it whole. You know, if you get all this flashing and everything underneath dried in nice and tight, you can cut that back for sure and have a limited visual on it. But if we painted that brown or stone coated it, you wouldn't even know it's there. Again, these are just some of the different things. This is 2 valleys meeting up and over where you're coming here. I can tell you with this valley being T-topped in the center, that's one of the trickier details to kind of miter those things and fold them all together. There are some products out there that you can use to make that process a bit simpler instead of trying to miter the two actual valleys together. Corex makes a product. It comes in it's a corrugated aluminum roll, and you can get it in either a solid butyl. Everybody know what a butyl tape is? Sort of a spongy, gummy sealant. Used a lot with metal roofing, but one side of it's either a solid butyl underneath, or you can get it with strips on either end, and it's malleable, okay? So when you run those two peaks together, you can take that roll, strip it out, and then just kind of hand form it to the shape, and you've got the aluminum wrap. Has anybody worked with lead before in anything? Okay, lead's a really good product when you get into tiles and some shakes. It's a very malleable metal. You can shape it to a lot of different things. Unfortunately, you can't use it with our product. Anybody know why you can't use lead with a steel product? Yeah, dissimilar metals, if you put them in contact with one another, dry, you won't have a problem. When you introduce water to that equation, you start to get oxidation. Okay, each metal has a different ionic charge, I think is what it's called. So they'll literally, like putting a battery on something, they'll eat each other away. With our product, you're close enough on the galvanic scale. You can use aluminum-based products. We also have a zinc aluminum coating that's on the steel. So those will have a pretty equal interaction with one another. But as far as copper and lead, from my experience, lead even more so, you want to try to stay away from it. I have seen some copper flashings that have been installed with our roof systems and have been on for 30 years with no issues. But from a manufacturer's perspective, if you ever did have that occur, we would not warranty that material if it oxidizes and rusts out or corrodes out. At the end of the day, again, something for your homeowner to decide or your customer to decide if they want to go that route. This here is showing you some of the notching. We'll get into this when we start applying roofs. But this is running a panel into a valley, okay? So we're going to cut off 4 inches of this top clip lock. So we'll snip up the lock, across the top, get rid of that top fold. We're going to do the same thing on the bottom. We're going to remove the bottom side. You can leave the face, but we're going to take off the underside. Anybody know why we notched this out? Well, yeah, it's going to be for water flow. So imagine this valley coming down. In the valleys, it's going to be most critical because you're going to get water that actually funnels into your valleys, and particularly if you've got long stretches of valleys. Has anybody here ever seen a long stretch of a valley? It could be on a church or a commercial building. It might be 80 feet up the roof line, and you got another 60 feet coming down this way. Not so much rain collecting in the upper part of the valley, but you get down towards the bottom and there's 6 inches of water running like a river in a good heavy rainstorm. That's because all that water is pooling up down there. So what we do with this notching is we're going to try to reduce the ability of that water from catching the bottom side of the panel. Okay, because we've got this, it's almost like a gutter. So as this is tucked in the valley, if you get water that builds up in there, it can catch that chute and run horizontally across the roof. Okay, it can take a little bit, because remember we've got weep holes that are punched in here. So when it gets to the next side lap, it's got a chance to drain itself back out there. But we want to limit how much water can possibly get through there just to not create any problems that we don't want. So it's going to be a 4-inch notch in our valleys, and then it's going to be a 2-inch notch everywhere else. Okay, so it's 4 inches in the valleys, 2 inches in your rakes and your sidewalls. Depending on how you do your hips, if you're using our channels, again, 2 inches there. And why do we do that? If you look at these water channels, it's about a 4-inch water channel on the valley, and it's about 2-inch on all of our other accessory pieces. It can certainly be a little bit bigger than that. It's not something where you got to get out your micrometer and get it right on 4 inches or 2 inches. Just eyeball it. Once you're snipping things every day, you're going to get a pretty good understanding of what 2 inches is. Now again, if you've got a valley, and that assumes you almost have a kind of a 90 degree or 45 degree valley, right? Have you ever seen a valley that runs kind of long this way instead of just coming straight up? Well, when you've got a valley that runs long this way, you're kind of changing the trajectory of that water channel. So now it's not a bad idea. You may have to cut that channel back 6 inches, or you may have to clip back 6 inches, or maybe even more. Again, you're really just looking to get rid of that clip in that water channel area, okay? So just be aware of that as you're working your way around this deck, and as Walt puts you guys all to work installing Decra roofs every day. This is actually a house over in southern New Hampshire. Again, just some of the stuff that you're not going to see in our standard details, where you've got multiple valleys coming down into these kind of choke points. One of the simplest ways I find to do these little deals is just get a sheet of pan metal in there. It makes for a real simple dry in that spot, and then you can recess your valleys back up and allow them to drain onto that pan, and just gives you nice continuous flow. Instead of trying to cram those two valleys down and almost having one block the other and impede your water flow, that gives you a nice, easy, smooth transition in there, and just lets you dump your valley metal on top of it. We talked about hips and multiple ways to do that. One of them is running a 2x2 down the center, installing our channel on both sides, cut your panel, drop it in, cap it. Some of our older systems, the batten systems, when we got to a hip, we actually run the panel in, bend the panel up, so the panel essentially becomes its own flashing all in one piece. And again, you can see we've got our starter strip notched out, our channel sticking out past 1 inch. How much do we notch the panel clip blocks going into a valley? 4 inches? All right. If you learned nothing today, those are some of the most critical things as far as making this system work, okay? I can tell you a lot of the claims that I get dragged into, they haven't notched any of those clip blocks, and it's catching water. It's a simple step. There's really no excuse not to do it. So just make sure that that's getting done. Here again, you see the rake channel coming down a hip, and then we've got a ridge that runs this way, so we got to make sure that this channel coming down is draining back on top of these panels. Everything's about drainage and making sure that everything's flowing up on top of something down below it. Roofing's, for the most part, it's a pretty simple concept. Water comes down. If there's something underneath, it's going to wash on top of that. It's going to keep washing on top. We've also got a product that we call debris blocker. Is anybody here familiar with like Cobra Vent? Okay. So it's a product similar to that. I don't know if we had any in here today. But it gets installed in our channels. So anywhere you have, like this is a sidewall detail. So it's a material just like the Cobra Vent, where it's kind of brillowy, right? So it gets wedged. You can either lay it down in the pan, or you can stand it up sideways and compress the panel into it. Most people stand it up and compress the panel into it. But it prevents pine needles, acorns, little helicopters, any kind of debris, leaves, twigs, from getting washed in here and eventually building up and creating water dams. It has a lot easier time getting in than it does getting out. So that material prevents that from getting in, but it's still porous enough to allow the water and the channel to function as it needs to function. Okay, again, here we're just showing the snipping of the starter to allow that rake channel to come down. I'm sorry, that XD sidewall channel to come down and extend past our eave for that 1 inch drainage. The valley metal sticking out. Head walls and aprons can all be done a bunch of different ways. Here's the 2 inch notching coming into the sidewall. Okay, we're just snipping off the back silvery part, and then right at this corner we're going to cut it off. We're going to leave that butt front nose, because that's going to be nice and stone coated. If you cut that out, you're going to see a big gaping hole in there. Not really going to be a performance thing, but visually it'll look a little funky. Finishing off into a head wall. Okay, it's a metal panel, so what is metal apron or transition metal made out of? Metal. Okay, so instead of using a transition metal or an apron metal, we can just use the panel and bend it right up. It's going to do the same job. Okay, Not the easiest thing to do because it's a corrugated panel. It's a little tricky to do that with just some hand benders. There are some manufacturers. We used to manufacture a brake tool. It's more of a crude brake than maybe what you're used to if you've done aluminum trim for window wrap or door wrap. But Malco, Swenson Shear, they make some tools that are made for braking stone-coated steel metal roofs. You can put the whole panel in there lengthwise and make one continuous bend. It makes it real super easy. It's a little bit of an investment to buy those tools, but if your boss is going to have you doing a job, make sure he buys you the tools. It'll make your life a lot easier. The tool will last you literally the rest. You will all be in the ground by the time that tool wears out. Maybe not some of you guys. You're a little bit younger than me, but
they'll wear those tools out. Don't worry.
And they also make what they call a guillotine cutter. Anybody here? Maybe you're all too young, but the old paper cutter you used to have in school, where it's got the little grid system on it and you can line your paper up and cut it. It's like that, but it's like on steroids. It's a 3/8 inch steel plate. It's got a flat base on the sawhorse, a flat plate on the sawhorse part of it, and then a bowed guillotine blade on the top side, and it lops right through the 26 gauge steel. So it's a great tool. Again, that'll last a very, very long time. When you dull down an edge on that tool, it's got some socketed cap screws you can pop off, spin the blade around, use the other corner. Once you drain that side down, you can put it on an angle grinder and square it back up and get a little bit more life, and keep doing that until you wear it down to the nubs. And then you can buy just simple replacement blades for a couple $100. Okay, the average job, 30, 40 squares, you're probably gonna drop $100 just in metal saw cutting blades, if that's how you decide you wanna cut it. The cutter tool might run you about $800-900, but it'll do thousands of squares worth of cutting. You know, dozens and dozens of jobs. It's gonna pay for itself in a half a dozen or so jobs. Not only in the cost of the tool versus the cost of the blades, but it's easier. It's easier to use, makes quicker cuts. You can put it on the roof if you really wanted to, if you had a flat spot or a lower pitch valley area or something like that, or you can set it up over the ridge line. Whereas cutting with a circular saw or something like that on the roof is something you absolutely don't want to do. Okay, there's little shards that get kicked off of that as you're punching through with the blade. And those little shards, even overnight with some mist or dew, can leave a stain on the roof surface. Okay, so just be careful of that. You do not want to cut it with like an angle grinder or a cutoff wheel. Anybody know why? What's that? Dangerous? Yeah, it's not the safest thing in the world. But the real reason is that it runs at a really high RPM, a lot faster than a circular saw or a table saw is going to run. So what it does is it heats up that steel, and it has the potential of burning back the zinc aluminum coating that's protecting the steel. Has anybody ever cut metal and seen it turn like blue or black? Yeah, so you're kind of like tempering that metal and heating it up real bad. That's burning back that corrosion protection that might be on that piece of steel that you're working with. So that's one thing that you want to avoid. If you're using a circular saw, you know, just be cognizant of how dull or how sharp that blade is. If you start seeing that it's having to really work to get through that metal and burning it up, throw it out. Obviously, the best thing you can do is just use a cold cut, whether that's snips or that guillotine shear. You know, besides the friction that's created just by cutting it, there's no extra heat that's thrown into that process. So a cold cut's always going to be your best option. Get rid of the idea of ever using any kind of cutoff wheel because it's just too hot. And circular saws, make sure that your blade's maintaining enough sharpness to get it through. Here we saw before the panel getting bent up and kind of becoming its own piece of flashing. Here you can see more of an apron getting set up and mitered around the corners. Has everybody worked with asphalt or composite shingles? Okay, so here, you know, you'd run your apron. Typically, you run your apron in front. You'll run another piece of step flashing here, splice it, fold it around the corners, put your little bead of sealant down through here, and go at it. This one, we've got slightly different method. Okay, we've got our channel that runs down. We're going to miter our channel. So for my money, I kind of like the apron method, only because it gives you a cleaner joint right here. you got smooth metal on smooth metal. Whereas by doing it with the panel, you've got the corrugation of the panel. You know, your fold might not be perfectly clean. You've got the stone coating that's on there. Just puts a little bit more in play as far as trying to get a nice tight miter joint on that corner and let that sealant really embed. So I like to do it with an apron and plan on doing it that way. When I was learning in this trade, whether we were doing siding, windows, trims, we always had a brake on site. Just grab some trim coil, break up what you need, and have at it. Here's one last thing. When you get into crickets, okay, particularly smaller ones like this here, for my money, the best thing to do is get some type of flat pan or flat sheet and just wrap it 2 pieces, bend it so it comes down the wall across, put the valley metal bend right into that piece, lap it over the ridge line, one side, done. Versus trying to get a little piece of our valley metal in here, a little piece of our valley metal in here, our side channel. You know, by the time you fill in our trims on something this small, you got like this much space to put a panel. And it takes forever. 2 pans, get your measurements, break it up, 10 minutes, bang, bang, you're done. It looks clean. It's super effective. So these are some of the things, you know, this is like done with a 4x8 sheet. These are some of the things where you can have the job perform just as well as you're ever going to need to. You can have it look good. But these are the things when you're actually out there doing this for a living, can speed up your process. Okay, and you want to always do a good job and you want to do quality work, but there's also kind of a balance between earning a paycheck so you can make your rent. So you have to move. Okay, so these are things. And a lot of these steps that you're going to learn are things that can help you speed up your process, because time really is money. You want to start with quality, but then you got to try to kick up that speed time to stay alive. Basically, with any kind of penetration, whether it's a pipe stack, it could be a tiny little sun bubble. So there's a lot more out there. As the incentives die off, maybe that scales back a little bit. But there's some companies that make solar standoffs that have very similar flashing mechanisms like we use for our panel. Basically, it's the mount that gets bolted down into the rafter with a little spun cap with a cylindrical standoff with a bolt on the top so you can mount your rails and everything to it. So any type of penetration like that's going to handle one of our underpans, whatever boot or flashing goes down on top of that, and then simply cutting the panel out to fit around it. Here's the more slides that you can see. We kind of already saw some of these. So we got our pan on, we got our boot on, we got our boot sealed around the sides and the top. We want to leave the bottom of this boot unsealed, is what I've always been taught. Anybody know why you leave the bottom unsealed? Yeah, so if for chance you happen to get something underneath there, it's not going to get trapped. It's still got a spot to drain back out down at the base. Okay. And once we got all this together, our pan and our flashing, that penetration is essentially watertight and dry. So now we want to cut the overlaying panel that's going to span this. We want to cut it out to fit around the neck part of our collar. Okay, and then down here where it's going to line up, we're going to make a notch. So Decra calls for putting a 2-inch notch in this bottom clip lock. Me personally, I like to take that 2-inch and split out wide, so you get a 2-inch and a 2-inch. That way, if something happens to come down and gets deflected one way or the other, it's still got a really good chance of catching one of those spots and getting out. Anyway, so this is how you do pipes. Okay, so here you can see we've got this cut out. We've got our 2-inch notch in the bottom. Again, I like to kind of not do that one and split it out side and side. But just some access point. It kind of doesn't matter, because once we get everything together and fitted, the opening that's created in there, we're going to seal that off anyhow. So everything underneath is really a fail-safe. 10, 15, however many years down the road, when your sealant starts to crack and needs a little touching up, you're still watertight with all the metal that you've got woven underneath that system. Okay. Same thing can be applied to your box vents or your power vents, sun bubbles, different types of penetrations, all done the same way. This is the debris guard product. Okay, this gets stripped out into our rake channels. You can see again the 2-inch notching, and it kind of aligns with that water channel that we've got stamped in there. Same thing in the valley, we've got our debris guard. Sidewall channels, you can install it. On the hips, just showing you the correct side lap as far as how they go together. This is just showing you, okay, this is running sort of a short course coming into a valley. I know this diagram's a little bit hard to understand what it is without seeing it first, but what that diagram is trying to show, if you're running over into a valley, okay, and you run, let me see if I can show it this way without getting in the screen too much. So we're running this panel over into a valley, and our valley's coming down this way, okay? So we run that last full panel over in towards that valley, and we're left with only a little teeny tiny triangular piece to finish off. Well, we kind of can't do that because we have to put screws down to hold that panel, and we're going to make penetrations right through our valley pan. So one option we've got with the 2XD systems is when we're running that, we can cut this panel back to 29 inches. It's going to create a similar spot of the panel that's going to act like the actual factory end, okay, in the field of the panel. Now we've got that shorter action panel with our rain channel. We can come in and finish with a longer panel. So that's what you're seeing here, is cutting back, eliminating that small triangle, cutting it back, and finishing off with a bigger panel. Now we've got spots to attach that as it's coming into the valley. Okay, you can do it this way, and you can put stitch screws through the nose, stitch screws through your course here, stitch screws through the next panel to kind of lock it in, almost like riveting it all together, where you're attaching the small panel to the big panel. But it's just as simple to cut it back that way and measure with a long full. What we've got available for tools, here's that stitch screw kind of being applied to a smaller panel going into a termination point. We've got panel vents that install, do the same thing as a box vent, but it's really gives the same airflow as about 2 box vents, standard box vents, but doesn't require any extra flashing. All you have to do is cut out a 5-inch high by 29-inch wide opening in your decking. As you can see in that upper left picture, that's the decking cut out. Line it up with where your panel is going to go. Install the panel vent just like a panel. No flashing required. Ridge venting, you can run them open or closed. We do not require our material to be vented. Okay, if you could consider a lot of asphalt shingle manufacturers, they require it as part of their warranty. You're going to keep down that heat, keep the shingles from burning up and basically deteriorating themselves from the heat retention. With our product, because it's an acrylic resin mixture that's on the steel, it's really not affected until you get to super extreme temperatures, which are, you know, pushing 300 degrees before it's going to adjust the panel. So we don't require it for our product, but at the same time, it's still good general building envelope practice to have ridge venting. Particularly in this market where you can get ice dams and things, and airflow and ventilation is key to eliminating that or reducing that. I don't know that there's a 100% rock solid way to eliminate ice dams when they want to happen in extreme conditions, but you can certainly do your best to limit ice damming by making sure you've got good ventilation and insulation in your building or your structure. Again, as far as venting our roof, very similar to what you'll see in the asphalt shingle industry. You're cutting out your opening up at your ridge line, put the ridge vent material down on top, and cap it right off. And here you can see the ridge vent material. It actually comes in a 2-inch strip. So one strip goes on either side and gets capped. And then we'll screw it all down. And the hip and ridge caps have similar receiver mechanisms like the panels do. But you can see one side's rolled back up underneath itself. The other side's kind of half lapped back on itself, so it gets screwed down on one screw this side, one screw that side, and your cap piece comes in, clips and locks right over the top. We've got details for short courses, which we don't have on this deck to try out, but this is where you've got, you know, like a contemporary style house where you've got maybe an eave line that comes down here and joins up with a higher eave here. And unlike asphalt shingles where you can kind of drop or choke up on courses, you kind of can't do that with our system. I mean, everything locks into place. You may have a fraction of an inch to kind of play with in there, but everything really goes where it goes. So in order to offset that, normally what I do, and I don't know if I have a great picture of it in here, I don't, but I would take my longest stretch of roof and kind of use that as my constant that I want to tweak from. Okay, so I'm going to be using full panels on all that long run. And then if you have a little bump out over a front entryway door where you got whatever it is, 3 feet wide, 8 feet wide, 10 feet wide, take that. You got to know what the exposure is of your panel. So with the Shingle XD, it's 12 1/4. We'll snap a line across where this top clip block's going to go, measure down in increments of 12 1/4 till you get to something on that lower plane that's less than. And then we can set a panel here, measure it, cut it, create our own hem on the bottom edge, hook that on, carry up with a full course. And if you tape measure works right, sometimes they don't, but if your tape measure's working right, when you get back up here, all your lines should align and everything should just continuously flow up the roof. You want to avoid putting short courses in the middle of the roof. Okay, if we were to put it's a little over a 5-inch course on each row of shingles, but if you were to put a 2-inch course for your shorty to start on the front edge, it doesn't have that other course to contrast to. Okay, so it's not going to look terrible. If you put a 2-inch course in the middle of your roof and you've got a 5-inch and a 5-inch above it, it's going to stick out like a sore thumb and look awful. So again, this is a lot more detail than you probably need or you're going to be able to absorb today, but just know that these tools are available if you ever need to check back for reference. And some tips and tricks, just things, some notes that are added that you may not think of as you're running through the job, but we found to be useful.
Keep an eye out for future training dates where we'll be doing hands-on demonstrations and collaborating with other manufacturers to provide education to the novice and experts alike in the construction industry.